and 13.
Sure, 3, 5, and 13. What other ones do we have to look at here? And again, we have plenty of time to go through any of these that we need to.
They also do 7, just read the second.
Sure. Yep, we can also look at question 7. Okay, so we've got a fractional exponent problem. We've got a cube root problem. We've got a rational equation problem. And we've got another rational. How about we look at one more, just to make sure we know how to solve these. How about we add question 2, because that one can be difficult as well. That's a square root problem. All right, are there any others that you'd like me to go through? Anything else? All right, well, we'll go ahead and get started with these, and we can add more if we need to. So this should be a little bit of everything. 1-6, I think, is one of the more difficult sections because there's so many different types of problems. So we're going to begin with question number 2 out of our homework. And this one involves a square root. Now, how do we handle the square roots? Well, there's certain things we need to remember. When we work with square roots, what's the opposite of a square root? A square, okay? So a square and square root undo each other. That's like addition and subtraction. Now, once we solve this out and we get solutions, we have to check them back in the original. So make sure that you're aware of that. So we're going to get solutions, and we're going to have to check those solutions back in the original. They might both work, only one of them might work, or neither one of them could work as well. So we're going to begin with this question here by isolating the root. It's already isolated by itself on the left. So that's step 1. Isolate that root. Now, what we do after that is we get rid of the square root by squaring both sides. So we're going to go ahead here and square both sides. Now, this does require a little bit of extra work, and that's why I picked this one, because this is one of the more difficult ones. What do we have to do with that 5 minus 2x? We have to take that 5 minus 2x, since it's quantity squared, and we're going to have to write it out, and then we're going to have to FOIL it. And I always like to try to divide my paper in half. So this will be a nice, neat step-by-step progression on the left, and this is my work on the right. So we go ahead and FOIL. So we've got 5 times 5, that's 25. And we do the outside times the outside. So that's a minus 10x. Inside and inside, that's another minus 10x. Watch your signs because negative 2 times negative 2 makes it a positive 4x squared. I'm going to write it in the correct order with the highest exponent first. So that's going to be rewritten as 4x squared minus the 20x plus 25. Now, going back to our original, we got rid of our root here. So that made it then 3x plus 10 on the left. On the right, we've got 4x squared minus 20x plus 25. So this is what we've got so far here. Now, we're going to have to factor this. We're going to have to factor it by grouping, probably. We're going to begin by moving it around and setting it to 0. So we're going to move that 3x and that 10 over. And that leaves me then with rewriting 4x squared minus 23x plus 15 equals 0. All right, so let's see who just came in. Let's see. Who just came in? Yep, Carl. Yep, that's what. So I want to make sure before I wrote down the wrong name here. You're welcome. And I do have everyone's homework graded as well. And it's all been recorded. If you took your exam late, I have that recorded as well. So this is what we've got. Now, what do we still need to do? Well, we need to factor. A lot of times students make the mistake of just jumping to our factors. Now, we can't just jump to our factors because of the 4. So we're going to take that 4 and we're going to multiply it by the 15. And 4 times 15, well, that makes it a 60. Now we need two numbers that multiply together to give you 60, add together to give you a negative 23. It's a positive 60, so that means they're both the same. Sign in the middle was negative, so they're both going to be negative. You should be able to hopefully see it as negative 20 and negative 3. So with that so far. Now again, we cannot just jump to our factors. We have to factor it by grouping. So we're going to take this negative 23x, and we're going to write this as 4x squared. That stays the same. And then we have a minus 20x and a minus 3x, because those go together to make it that minus 23. Now we can factor by grouping. So we're going to group the first two pieces together, and we can factor out a 4x, and that's going to leave you then with an x minus 5. The next two pieces, it begins with a negative, so we're going to have to factor out a negative 3. And that leaves you then with an x, switching your signs, minus 5. Those are the same. And that leaves me then with 4x minus 3 and an x minus 5, and that still equals, again, 0. So we're mostly done. Now again, when we get our answers, we're not done because we have to check those answers. So our possible solutions would be 4x minus 3 equals 0. So 4x equals 3. Divide by your 4. And that leaves you then with x equaling 3/4. What about the other one? Well, the other one is x minus 5 equals 0. Moving it over, x equals then 5. Yeah, I should have wrote it in the opposite order. It doesn't matter though, because what happened? We took that x minus 5 and that goes here, right? And if that's gone and that's gone, what's then left over? 4x and a what? Yep, minus 3, right? Yeah, I should have probably wrote it in the other order. It doesn't matter though. But normally I would have wrote that x minus 5 first. But order on this does not matter because it's all community. But does that make sense now? Because those are gone. So that leaves you then with that 4x minus 3.
And so when you do your check, you'll plug it back to the original, and then you plug it back into
You'll plug it back in the original with the square root. When you check these, you're going to plug it back into the original problem with the square roots. Now, if you have a fraction, you're going to use a decimal. Okay, so 1 or 2 decimal places is more than enough on these square roots. So we've got our possible solutions. Now let's go ahead and check them. And we're going to check them. We'll start with x equals that 3/4, and that one comes out nicely as a 0.75. And we're going to check, and we're going to check it in the square root of 3x plus 10 equals 5 minus 2x. And plugging it in, that is then the square root of 3 times 0.75 plus 10, and that should equal 5 minus 2 times 0.75. Okay, so we're going to have to check them individually. Now let's see what we get. We'll do the root first. So we've got 3 times 0.75 plus 10. That gives you the square root, 12.25 on the left. On the right, we have 5 minus 1.5, and that leaves you with a 3.5. And what about the square root of 12.25? Well, that square root comes out to be 3.5. So what do we notice here? We notice those are what? Are the same, right? I'll adjust the focus a little bit here. Okay, so adjust it a little bit here. Okay, so that's what we've got so far here. Is everyone okay with that? So that one does work. Now, what about the 5? Let's check the 5 next. Okay, we check that 3/4. So just use the 0.75 to check. Next, we're going to check that 5. And so if I check that, then I have 3 times 5 plus 10. That should equal 5 minus 2 times 5. And this one is not going to work, because 3 times 5 is 15, add 10 more, makes it the square root of 25. On the right-hand side, 5 minus 10 makes it a minus 5, and 5 does not equal a negative 5. So 5 is not going to work. So what's our only solution? Our only solution is 3/4. Do we kind of see how that one was done? And that's why I picked that one, because that was a more difficult one. So let's review what we did. We took our original problem that had a square root. We had to square both sides. So let's look quickly back at the original, and then I'll move it back down so we can see. So we took our original, we squared both sides. Then we set it to 0. Then we factored it. We had to factor it by grouping. We solved it. We got our 2 possible solutions. We checked them. And the only one that actually checked out was that 3/4. Because the 5 didn't work, because the sides were not the same. And I think that was one of the most difficult problems on this assignment. Question 3 is next here. So question 3, we've got x to the 1/2 power equals 3x to the 1/4 power. To solve this question out, what we need to do is we need to get rid of our fractional powers. So I've got a 1/2 and I've got a 1/4. So to get rid of all of my fractions, the least common denominator of 2 and 4 would be 4. So I'm going to have to take both sides to the 4th power. That's going to clear out those fractions. This actually is a lot easier question to work through. So 4 times a 1/2, because remember, exponents multiply. So 4 times a 1/2, that leaves you with an x squared. Now also remember that 4 has to be distributed through. And it's not 3 times 4, it is 3 to the 4th power. And remember, 3 to the 4th power is 3 times 3 times 3 times 3, which is 9, and 9, which then makes that 81. So that piece came out to give you 81. So then that's going to be 81. The 4 and the 4 cancel, so that leaves you with an 81x. Is everyone okay with how I cleared those powers out? Now, commonly made mistake is someone's going to take 3 times 4. It's not 3 times 4, it's 3 to the 4th power. Write it out and multiply. Now we can finish it. So we move that 81x over with subtraction. That leaves me with x squared minus 81x equals 0. And now we can factor. So this is a binomial on the left here. So we can factor an x out. And that's going to leave you then with an x minus 81 equals 0. And what do we have for our two solutions? Well, one of them is simply going to be x equals 0. And what about the other one? That's x minus 81 equals 0. So that would leave you then with x equaling 81. We do not have to check these. So don't try to plug it back in and check it. The only questions we have to check are going to be questions that involve roots and fractions. So we got it all cleared out. We moved it over, set it to 0. We factored that x out, okay, and that gave us our two solutions.
So is there a reason why we didn't set it up the same way we did those like two where we took 81 for like would be like factoring out 81 where we can put x squared plus 9x plus or it'd be minus 9x and then it'd be 81.
Okay, I see what you're saying. We can't factor that as a perfect square because in a perfect square, we wouldn't have that x. See, if we had x squared minus 81, then we could factor that into x plus 9 and x minus 9. But because that extra x there inside that 81, we have to factor that x out first. And then that's not a perfect square anymore because that x is not squared now. Does that answer that question? Okay. So that was question 3. Question 5. Question 5 is like question 2, only it's much, much easier. And we are going to solve it. We're going to get our solution, and I think we'll only have one, and then we'll have to check that solution. Now, this one is a little bit easier because we don't have to FOIL out the right-hand side. How do we get rid of a square root? We use a square. So how do we get rid of a cube root? We use a cube, right? Okay. So we're now going to cube both sides. And if we need to, we can write that 4 cubed over here. You can use a calculator if you want. Doesn't matter to me. I like to just write them out. And that's 4 times 4 times 4, which is 16 times 4, which is then a 64. The cube and the cube root, that cancels, and that leaves you then with an x plus 7. So we're at this point. Now, what do we need to do next? Well, we can just solve it. We're not going to have to factor it because this is linear, right? No squares, none of that. We can directly solve it by simply subtracting the 7. So this is linear, so no factorings involved. And that gives you then 64 minus that 7. And that comes out to be 57. It's going to work, but we'll go ahead and check it because with these roots, you always need to check. So we're going to check x equals 57. And so that's going to then be the cube root of 57 plus 7 equals 4. Well, 57 plus 7, that's a 64. And we already know that 4 cubed is 64. So that means the opposite is also true. That means the cube root of 64 would then be 4. 4 cubed is 64, so the cube root of 4 of 64 is also 4. These are the same, so it does in fact work. So our answer here would now be a 57. Right, is everyone okay with that so far? I know a lot of times what happens is there's so many different techniques that a lot of times students get confused as to where to begin. But once you get started, it's usually not that difficult. Once you get past trying to figure out what am I doing. Question 7 involves fractions. And with fractions, we need to find our division by 0. Because remember, we cannot have division by 0. And we're going to begin by factoring these denominators. So I'm going to take this x squared plus 5x minus 24, and I'm going to factor it. So I need a minus 24 here. That tells me then that one number is positive. And this is question 7, by the way. One number is negative, larger is positive, smaller is negative. So let's see what we've got. We can use a 12 and 2 is not going to work. How about we try a 3? 3 and 8 will work. So we need a positive 8 and a negative 3. That factors into x plus 8, x minus 3. Before we clear our fractions, we need to figure out what numbers are not going to be in the domain. So everything has been factored. We're going to look at our denominators. We can work them out, or we can just look and see what numbers are not going to work. Well, when I look at these, what number is not going to work on the first one? What's going to give me division by 0 here? Just by looking at it, it would be x equals 3. Right? Why would x equals 3? Let me write a bit here. Why would x equals 3 not work? Because if you plug it in here, see, that would give you division by what? 0 down below, wouldn't it? Okay, so what numbers are not in the domain? The numbers that are not in the domain are x equals 3. And what else is not in the domain? X equals a negative 8, right? Because negative 8 plus 8 would make it what? 0. Same thing with these. Now we can proceed to clear out our fractions. So we look at what we've got, and then we'll look at how we would clear them out. So let's rewrite it one more time. The factored version. I'm going to leave myself plenty of room here. And then I'm going to clear out these fractions. So what we want to do is we want to get rid of all of the fractions. So for our first one, we have an x minus 3 below. So to get rid of that piece right here, we're going to use an x minus 3. This piece needs an x plus 8, right? Because that's going to get rid of that one. And that one's going to get rid of that one. And then, let's see, did I factor something down? Yeah, I think I wrote down one. It should be a 3, not a 5. Sorry about that. Should be a 3 there. My mistake. Okay, so that's going to be a 3 there. So that'll get rid of all of our fractions, won't it? Now let's see what we're left with. Okay, so what do we have here? When we distribute through, what I like to do is just go through and cover them up. So the x minus 3 and the x minus 3, those are going to cancel out. So what's left over on our first fraction? We've got a 3 in the numerator, and then a what? X plus 8, right? Because those went away. Repeating the process on the next one. Those cancel. So if those are gone, then what do we have left? We have 7 times x minus 3. And what about on the right-hand side? Well, those all completely cancel. So the right-hand side, all we have left is a 5. Is everyone okay with that so far? Now, what do we need to do? Clear out our parentheses. This one's going to be linear, I believe. So we're not going to have to factor it. This one's actually a little bit easier than some of the others. So we're going to distribute our 3 through and our 7 through. And that leaves me then with 3x plus 24 plus 7x minus 21 equals 5 there. But not 24, I think it should be 32. Yep, is 8. Yeah. Well, no, I got it right. Yep, 3 times 8. Sorry about that. Wasn't thinking. 3 times 8 gives you that 24. The 3x is there. 7 times 3 is, or sorry, 7 times x is 7x. And 7 times a negative 3 is a negative 21. So let's go ahead and combine 3x and 7x. It makes it 10x. And then we've got a 24 and a minus 21. So that makes it a positive 3. Move that 3 over with subtraction. And that gives you 10x equals 2. We'll divide by our 10. And we're going to reduce this down. And this then reduces down to 1/5. Is this going to work? We don't have to plug it back in. We need to check it with our domain. What numbers are we not allowed to have? We are not allowed to have 3, and we are not allowed to have a negative 8. Well, 1/5 is neither one of those, so the 1/5 is our answer. If your 1/5 would have been a 3 instead, then you would have no solution. This one, once you cleared out your fractions, we did not have to factor. We just distributed through. It gave us a linear equation, and we solved that linear equation. Question 13. Question 13 is another fraction problem. Now, this one's going to require us to factor. So it's actually a little bit more difficult than the last one. So question 13, we've got a minus 5x squared minus 4 over x minus 4 equals a minus 15x over x minus 4 plus 4. What number is not in the domain? Let's go ahead and find that. Well, the only thing that we have to worry about is that x minus 4. So not in the domain. Is x minus 4 equals 0. So x equals 4 cannot be part of that domain, right? Is everyone okay with that so far? Now, there are 2 ways of solving this one. And they're about equal on the level of difficulty. I could bring this fraction over and combine it with that one, since they have the same denominator, and cross multiply. That's one way. Or I can just clear the fractions by multiplying. I think I'm going to clear the fractions by multiplying. So I'm going to multiply everything by an x minus 4. And that's going to cancel out all of my fractions. But again, you could bring it over and cross multiply as well. So the 4x, or sorry, the x minus 4s, they cancel. So that leaves you with the minus 5x squared minus 4 equals, then those cancel, a minus 15x. And don't forget, we have 4 times that x minus 4 because there's nothing to cancel there. We'll go ahead and distribute that 4 through, combine like terms, and eventually set it to 0. So distribute that 4 through, and that's going to give you a minus 15x plus 4x minus 16 on the right. And it doesn't matter how we want to combine them or what we want to do. I'll just add in an extra step. I'm going to go ahead and combine that minus 15x and the 4x. That makes it a minus 11x minus 16. I would go ahead and move everything to the right. That way your x squared stays positive. If you don't want to do that, you'll move it to the left, but you'll multiply by a negative. You'll end up with the same equation either way. So I'm going to go ahead and add a 5x squared over. And I'm also going to add a 4. So we're making progress here. Rewriting, we now have a 5x squared minus 11x minus, we got 16 minus, or sorry, minus 16 plus that 4. That's going to make that a minus 14. This one, again, is going to be factored by grouping. So first times the last. Did I make mistakes? Do what now? Let's see. Where did I make the mistake at? Oh, yep, you're right. Yes, 12. My mistake. Sorry about that. At least we caught it before we started to factor here. So now we have 5 times a negative 12. Well, that makes it a negative 60. And we know we need one number positive, one number negative. Middle number is negative, so that means my larger number is negative. Smaller number is positive. It ends in a 0, so it has to have either a 5 or a 10 in it. So let's start with 5. 5 and 12 is not going to work. Let's try a 3. 3 and 20 doesn't work. Let's see. How about we try a 4? 4 and 15. So we need a negative 15 and a positive 4. Now we can split that middle up. And because of the 5, we have to factor by grouping. So we've got a 5x squared. We've got a minus 15x. We've got a 4x. And then we've got a minus 12. First two pieces, what can I factor out? Yep, 5x can come out of my first two pieces here. So that's going to come out. And that leaves you then with an x minus 3. The next two pieces, looks like a 4 can come out. And that's going to leave you with another x minus 3. And I'll put these in the correct order this time. So now we've got an x minus 3 out in front. So gone and gone. What's left over? 5x plus 4. That equals 0. So what numbers are my solutions or possible solutions? We've got x minus 3 equals 0. So x equals 3. Is that going to work? Yes. Why is that one going to work? Okay, what number does not work? 4. So 3 is clearly not 4, so that one works. So there's one of them. Let's get the other one. Okay, so my other one is 5x plus 4 equals 0. So 5x equals a negative 4. Divide by our 5, and that gives me my second solution, which is x equals a minus 4/5. Both of them do work. So those would both be our answers. Do we have any others to look at out of 1.6? 10? Sure. Oh, which one? Okay, number 10? Sure.
20.
Oh, yep, 10 and 20. Okay.
Just number 20.
Oh, sure. Sorry about that. Okay, so we want number 20. Now on question 20, we're not going to have to solve out and work through question 20. Because question 20, what does it say? It says find a number or numbers that are what? Not in the domain. So we're going to work through the denominators by factoring if we need to. And then we're only going to find the numbers that do not work. So we're not going to have to clear the fractions, and we are not going to have to solve it. Because question 20 would be a problem. If you try to solve it, it would be difficult. It would take quite a while to work through. So question 20, all we want to do is find the number or numbers that are not in the domain. And we've got this. We've got x over x minus 4 minus 1 over x minus 6 equals 11 over x squared plus 2x minus 24. And all we're looking for is the number or numbers that are not in the domain. So we're going to take that x squared plus 2x minus 24, and we're going to factor it. And it should be pretty easy to see the two numbers. It's a negative 24. Middle's positive, so that means one positive, one negative. And we're going to use a 6 and a negative 4. So that factors then into x plus 6, x minus 4. This one would be complicated to solve. So we're not going to solve it. All we need to do is figure out the numbers that are not in the domain. So let's see what we've got not in the domain. X minus 4 equals 0. So that means 4 is not in the domain because that gives you division by 0 there. Then we've got x minus 6. Moving that over, that gives you x equals 6. So it's not in the domain. X plus 6 equals 0. Moving that over, we've got x equals a negative 6. And that's also not in the domain. We don't have to worry about that x minus 4 because that's already been taken care of. So what are the three numbers now that are not in the domain? These cannot possibly be solutions. And what would they be? They would be 4, 6, and negative 6. Those are your numbers that are not in the domain. We're not solving that one because it only asks you to find the numbers that are not in the domain, numbers that cannot possibly be solutions.
So when you rewrote it, and then further out the paper,
Yep.
so it's on the bottom, the denominator is x plus 6.
Oh, did I make a mistake? Oh, sorry about that. Yep. Not paying attention this evening. My mistake here. Okay, so that should be a plus there. Yep, so then that piece doesn't work. Okay, so we've already taken care of it.
4 and negative 6.
Right, yep. Yep, because that one should be a -6 there. Sorry about that, I just wasn't careful there. But yeah, so the only numbers that are not in the domain, just so we know, the only numbers that are not going to be in the domain are 4 and -6. Any others to look at in 1-6? We'll go ahead and just barely touch on 1-7, and then we'll take a short break. 1-7 is inequalities. And the first part of 1-7, you're already familiar with. It's the second part where it's more difficult. So what we're going to look at before break is linear inequalities. And let's just quickly review how to graph things on a number line. When we go to graph things on a number line, strictly greater than, strictly less than, those get parentheses. Greater than or equal to, less than or equal to, those are going to get square brackets. Now, negative and positive infinity, they both get parentheses no matter what. So they both get parentheses. Some textbooks and instructors use open and closed circles. I like parentheses and square brackets because it goes right into interval notation. So we're going to be graphing these out. Now, when we talk about inequalities, we also have to remember this fact. When you divide or multiply by a negative in an inequality, what does that do to the inequality symbol? Does anyone remember? When you divide by a negative in an inequality, that makes your inequality symbol do what? Flip around, right? Remember that? So when you divide or multiply by a negative, flip your inequality. Flip that inequality symbol. So if you divide or multiply by a negative, you're going to have to flip that inequality symbol. So we'll do a couple of these. We'll probably do 3 of them, maybe 4 if we need to, and then we'll take a short break. These again, though, are ones you're already familiar with. These are linear inequalities. So we're going to go ahead and solve and graph this one out. Five x plus 4 is less than 3 times x minus 8. Okay, so we're going to have to solve and graph this one. Now, we should be familiar with this. This should be nothing new. We know how to solve these. Distribute that 3 through, like we've done many, many times before. And so that leaves you then with a 3x and a minus 24 on the right. You've got that 5x plus 4 still on the left. We're going to move that 3x over, and we're going to move that 4 over. So that leaves you then with a 2x. Inequality symbol stays the same. Minus 24 minus 4 makes it a minus 28. I haven't switched that inequality symbol. Why not? Did we ever divide by a negative number? Nope. We're going to divide by 2. Still going to keep it the same way because we're dividing by a positive 2. And 28 divided by 2, that should be a 14. So that's going to be a negative 14. Now we need to graph it on a number line and get our answer in interval notation. So here is our negative 14. I always like to keep my x on the left. That way it's easy to figure out which way to go. If your x is on the left by itself, look at your inequality. Which way does it point? It's going to point to the left, so we're going to shade to the left. So that means we're going to be shading back to the left here. And it goes out to negative infinity. In interval notation, in the same order on the number line, do not mix them up. Negative infinity is on the left. Negative 14 with parentheses also is on the right. Is everyone okay with that? Pretty simple on those, not difficult at all to do. Let's do one where we have to switch our inequality symbols around by dividing. After break, we'll do quadratic inequalities and rational inequalities. Those are considerably more difficult. These are very simple. Okay, how about we try and solve and graph now? Let's see, how about minus 8/3 x plus 2 is greater than or equal to x minus 4. I picked this one because we've got fractions again. So let's go ahead and get rid of our fractions. So multiply everything by a 3. It's going to be easy enough to do there. 3's cancel. That leaves you with a minus 8x. 3 times 2 makes it a 6. Inequality symbol stays the same. 3 times x, that's 3x. And 3 times a negative 4, well, that's a negative 12. Let's go ahead and finish it out. So move that negative 3x over. And move that 6 over as well. Leaves you then with a negative 11x is greater than or equal to. Those cancel. 12 minus 6 is a minus 18. We're going to divide by a negative 11. And what happens when we divide by a negative number? That's going to switch your signs out. So that's going to switch them out. And that's going to make that then x is now less than or equal to, negative and negative makes it a positive 18 over 11. We'll put this on our number line. Here is our 18 over 11. It's pointing to the left, so we graph it to the left. It's less than or equal to, so we're going to have to use square bracket here. Goes out to the left with negative infinity on the left. So then our answer looks like negative infinity, comma, 18 over 11 with the square bracket. One more, and then we'll take a short break. This one's a 3-part inequality. And this one, we're going to have to switch our sign. We're going to have to be very careful when we work it through to make sure we put everything in the right order on the number line. Let's use a 3. And how about we have a minus 4x plus 7 in the middle. So we're going to have to solve this one in graph. And this again is called a 3-part inequality. I'm sure you've seen these many times before. Move that 7 over. 5 minus 7 makes it a minus 12. Got a minus 4x in the middle. 3 minus 7 makes it a minus 4 on the right there. We're going to divide by a negative 4. That then switches all of your signs out. So watch that. It's going to switch out your signs here. And we have a negative 12 divided by a negative 4. Well, that's a positive 3. Negative 4 over negative 4 is a 1. I picked this one because a lot of times students make a mistake. Now, we switch the inequality symbols, right? What else do we need to do? When we put them on the number line, we also have to what? Switch the order, right? Because they have to make sure they're in the correct order. So 1 is going to go on the left because it's the smaller number. And what about on the right here? On the right, we have a 3. So what do we have at the 3? At the 3, we have parentheses. And at the 1, we have square brackets. Our answer is going to be in the middle. So then in interval notation, it's going to be square bracket 1 to 3 with parentheses. Is everyone okay with these? So we're going to take a break. We're going to come back. And we're going to look at quadratic inequalities. So let's take a short break. And let's meet back here at 7:50. So try to meet back here around 7:50.